Hope students, shall we start? Only two students are there here. Shall we start? Probably Mr. will have left the program. Shall we start, students? Even though no response, even if I ask any questions, there is no response. If I ask any doubt, there is no response. Okay, start sharing the screen. Right, this all, and anyhow I'm starting the regular class of soil colloids. Right, students, I think not okay. The two numbers are there. Anyhow, students, do you have any idea regarding with soil colloids in your past career of BSc? In the past 4 years, I think now we are in a final year. Is there any idea? Any idea, students? Only two students are there. Please, at least you two should be very active in this class. Any idea regarding the soil colloids? What are the colloids and what is their role in soil chemical and physical scenario? Any idea, students? Please be interactive. Only two students sit there, so there will be a good healthy discussion will be prevail between us. Students, any idea regarding with soil colloids? Whether you have heard about what is soil colloid?
They play important role in soil fertility, ion exchange.
Okay, yeah, fertility. Okay, one thing accepted, ion exchange and fertility. Very good. One answer I have got. So we have some basic idea what is soil colloid. Now today we will see the very fundamental aspects of the what are the colloids and what are their properties and what are the different kind of colloids there. We will see in this session about only soil colloids. There are many different things there in chemistry. In the past, hardly within 2 3 weeks we will complete the entire syllabus of soil science. So up to now, the within the three classes there will be only chemistry classes. Now let us see today what is soil colloids. We will see colloids. So very first we will see some fundamental aspect of colloid. Right, students. So colloid is a colloidal state. Generally, in intermediate, in your +2, have I ever read about the surface chemistry? Have you ever read? Have you read the
Yes,
surface
sir.
chemistry intermediate?
Yes, sir.
What are the terminologies you have heard in surface chemistry? What are the words you have read? If you remember, please, you are very young, so definitely you have a good memory. What you have read in the surface chemistry? What are the terminologies you have still in your brain? Please say one or two terminologies. Any term?
Adhesion, cohesion,
Okay, adhesion, cohesion, and
dis
still, huh?
dispersion.
Okay, dispersion. Add. You don't read my slide.
Ah,
Just
no,
think what you
sir.
have. What, Amma? What? Come on. Only two students. We should have the class should be very interactive, not like, just like a one-way traffic. You said cohesion, adhesion. Okay, some extent I'm expecting dispersion also. Is there any two major terminologies in surface chemistry of intermediate? So both are from
Absorption.
very good. Absorption. Regularly we used to listen these words in fertility course. Yes. Any other? Two more? Yes, you're coming, you're here. You're almost very completed more major terminologies. Two terminologies are there. Okay, I will give clue. It is linked with dispersion.
Emulsion.
Emulsion. Okay, it is a result of this colloidal. Okay, emulsion is a one part of terminology. Okay, another one, dispersion. So both are from Board of Intermediate Education only. So I think you know what is the surface chemistry terminologies, all those things. Two words. That two words will start with word called dispersion, and for the dispersion you have to add one more word. Okay, I will give one example. Then can you answer if I give an example? Please unmute you, both of you. We are only three students. So me also one of the student. So unmute yourself and let's discuss today's class. Very jolly and very happy. Should not be like a very formal class. Okay. Okay, students. For example, uh, I have a what can we do? Take one spoon of sand. You know what is the sand? Okay. Mix that one spoon of sand in one glass of water and mix it. Okay, instead of sand, you take clay. Clay is a good example for our class. Take one spoon of clay, mix in water. Now, there are two phases are prevailing here. What are those? Clay is called with one terminology. What am I?
Centripetal and
Centrifugal in the what is the
Lyo,
need of here centrifugal?
Lyophilic, lyophobic.
Very good. This is one terminology. Good. This is a lyophilic, lyophobic. One terminology. Just lyophilic means what are the material which love the water. That means what are the material which mingle with water. Phobia means fear. So those materials will
fear.
not mingle with water. But okay, this is one type of terminology. One more terminology. You're coming very close. Clay and water. Clay is called with one.
Crystallization.
What am I?
Crystallization.
Crystallization will comes in the crystal chemistry. What now? There is next tomorrow. Yesterday, next class. Dispersion phase and dispersion medium. Have you ever heard this?
Dispersion.
Have you heard about dispersion? Both of you. Have you heard about dispersion phase and dispersion medium?
Yes,
Oh, my
sir.
internet is unstable, right?
Yes, sir.
Okay. Now I've given one example. In that, medium, dispersion medium, water or clay. Come on. If you know means no.
Yes, sir. Dispersion. Medium means
Yes.
What?
Okay. Dispersion medium means medium. The word itself you have to take one yardstick.
means in which the what we are dispersing that one will means dispersion medium will be more. Dispersion phase means the structure or the shape of
Okay. Okay, very
and
good. You have given good definition. In my given example, I have mixed 1 gram of or 1 spoon of clay in glass of water. In that, which one is called dispersion medium and which one is called dispersion phase?
water is medium, sir.
Okay, dispersion medium. Very good. That's all. These are terminologies. I almost now see today you both of you had almost completed all the entire class today because you have said many terminologies like what is you have said about you have spoken about the cohesion, adhesion, dispersion medium, dispersion phase, and especially you have given some very advanced example of coagulation and emulsion. You have spoken many things. So all these terminologies, all these words and all these things are belongs to our colloidals. Actually colloid is only one part in surface chemistry, but being an agriculture graduate or being a soil scientist, we will restrict ourselves to the soil studies only. So we will see what is the soil studies. Very first slide, student, just see this. So colloidal state refers to the two-phase system. What are those phases we have discussed, in which one material is very finely divided state and dispersed through the second phase. Just now I said. Okay, just I have said that is the mean. That's the clay, and why I said clay means clay will act as a colloidal particle because of its size. So the example, what is the example? Solid in liquid. Just now I said water in clay. And liquid in gas, fog or cloud in atmosphere, just like. So you may know it is very difficult to remember this example, but this example is very familiar in our agriculture. Solid in liquid, that is dispersion of clay in water. It's a two-phase system. Colloidal system is a two-phase system. We have one phase finely divided state, and another one is second one is dispersed in the second phase will be dispersed. And the clay fraction of the soil contains a particle of less than 0.002 millimeters in size. So almost it will satisfy the colloidal activity. So naturally, what is a colloidal means? If any particle want to possess any colloidal nature, the particle should be less than 0.001 millimeter size, possess colloidal properties are known as soil colloids. Remember this word, student. This number 0.001 millimeter size possesses the colloidal particle is known as soil colloids. It's called the soil colloid. So this is what very fine and very basic fundamental importance. Students, I'm again and again I'm saying, be strong with fundamentals. Automatically you can answer any applied questions in the examination, because nowadays agriculture is moving ahead. Questions are becoming very tricky. And next one, students. Now we will see some general properties, students. What are the general properties of soil colloids? Size. Size, then generally inorganic organ extremely size, almost how much size it will be there? It will be 2 micrometers in diameter. In diameter it will have only 2 micrometers. Naturally we can't see the colloids with our ordinary microscope, or it's sorry, ordinary eye we can't see, but we can go with very electron microscope. If you see any colloid electron microscope, it will be like this. If you see any colloid in an electron microscope, we can see the colloids will be like this, in electron microscope. So regarding with the size, it is almost the diameter should be around 2 microns, very less, very small particles. And actually it is very finely particle, but not having any quality to become an atom, students. Remember these words. Many students will confuse whether colloids will become as an atom or something. But no, it won't become. It is very finely particle, but will not reach chemistry very deep. This is the regarding with the size of the soil colloids. In this slide, you have to remember this word. Remember this word, students. For examination purpose, remember this word. Smaller than 2 micrometers in diameter. This is the size. So once very good. Lavanya. Okay, fine. Yeah, she's coming. Next. Surface area, students. Okay, students. Before going to discuss this, what is surface area, students? I think now one number is increased. 3 members are there. Okay, Nandini and Swati, you please be calm. I will ask Lavanya this question. Lavanya, welcome to the class, though you are late. Do you have any idea regarding the surface area? Please, if you're interested to talk in mic means you can type, or you can type in the chat. Do you have any idea? Students, you're almost fine regarding the surface area. Please answer. Okay, I think Lavan is not interested to answer. Okay, rest all students, that's 2 of you. Can you give an answer? What is the surface area? Come on, please answer. Please talk. Yes. I'm getting some answer.
Surface area
The
means
total area.
the total area which is occupied by that particular.
Okay, you're giving definitions. Can you give an example? Please be practical, students. Example means, okay, I will give one example. You take one beaker. Quite for understanding, you take one beaker. Okay, In that beaker, take 100 ml beaker, small, or 50 ml beaker, very small beaker in laboratory you may see. You add for that sand in one beaker. Okay, and another beaker you take clay. Which one will have more surface area, sand or clay? Sand or clay?
Place.
Clay. Very good. Finally, Lavanya opened his mic. Her mic. Anyway, clay will have more surface area. Why? 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 Enduku? Why? Why the clay has more surface area when compared to the sand? Because students, size was very less when compared with sand. Clay particle size was very less, so naturally as the size decreases, surface area will be increases. So that's why clay plays a major role in our fertility, because all the exchangeable reactions will be taken place in clay only, clay minerals only. We will see in the next class. This is the class we'll talk about the clay minerals. So clay minerals or clay will act as, clay has more surface area. That's why it plays a major role in soil fertility. So that's why surface area is very important. Coming to our class, surface area. Now you can see here, because of the soil, because of their small size is very less. All colloids have a large external surface area per unit mass. Just now I said, na, if you take 1 gram of sand or 1 gram of clay, generally clay will have more surface area when compared with sand. So in the same logic is applied here also in colloids. Size is very small. The colloids have a larger external surface area. How that example means, the external surface area of 1 gram of colloidal clay is 100 times than that of 1 gram of 1,000 times one gram of coarse sand. That means if I want to, if I want to speak in very well, if you take 1 gram of clay, 1 gram of clay particles, it will be, their surface area is 1,000 times more than 1 gram of coarse sand clay. This is the meaning. That's why when the size decreases, surface area increases. The colloidal surface has that much reaction surface is there. Certain silicate minerals extensively internal surface area are going to be like a plate-like crystalline unit and make up each particle often generally extend to the external surface area. Generally, this silicate sorry, 1 minute. Yeah, certain silicate have a extensively internal surface occurring between the plate-like structures. So, in some crystal lattice, you can see spray, because during that layer lattice, you can see internal some gap will be there. So internal surface according to the plate-like crystal units, and they make up each particle, and often generally exists than the external clay. In the clay, silicate clay lattice, what will happen means, students, due to those internal clay lattice, that means you may aware that where is the point? I'm not getting. Right. What will happen means, students, you may aware that clay lattice, 1:1, 2:1, 1:2:1. You have seen many things. This is the layer lattice. So during this layer lattice, internally also will provide major surface area for the reaction. So that's why clay minerals, they see this area, because already we have some reaction surface area here. We have here some minerals will be, some reaction will be taken. Reaction means nothing but our exchange, CEC, all those mineral exchange will be taken place here. And also there will be some area of reaction here also in between the crystal layer lattice, in between that crystal units. So they will make up some, each particle will make up a very greater extent of surface area. There will be more surface area when compared to, due to this layer lattice in crystal clay, silicate clay minerals. That's why silicate clay minerals will play a major role in our fertility status. That's the reason, students, why the clay is plays a major important role in fertility. So here there is one calculation. Total surface area of soil colloidal ranges from 10 meters square per gram. If you take total surface area of a colloidal, if you take a colloidal of for clay, the surface area will be 10 meters square. For 1 gram, it will give a 10 meters square of surface area with only external surface. That too, it's only external surface, students. if we included the internal surface area also, it exceed up to the 800 meters square per gram. Consider the internal clay lattice, that internal in between the clay lattice. If you see the, if you consider that surface area also, it will be around 800 meters square per gram. That is the meaning, students. So you please remember this logic, students. So we are preparing for a competitive exam, not for a semester exam. That's why you should be very careful with these logics. Small surface, small size, more surface area. So 1 gram of colloidal is more than 10,000 times more. So this logics, sometimes this logic will helpful to you answer in some applied questions. And also colloidal surface area is up to 15 centimeters of hectare of clay should could be around 70 some 7 lakh kilometers square per gram. If you take the 15 centimeters of hectare clay of clay soil, the surface area, the colloidal surface area will be around 7 lakh kilometers square per gram. Per gram, if you for 1 hectare, for 15 centimeter of hectare clay, it will be around the 7 lakh kilometers per gram. So this is the important things regarding with the surface area, students. Surface area plays a major role. That's why during our soil analysis also, we always bothered about how much percentage of clay is there, how much thing is, because more clay, more reaction. And also being it's a only clay also, it's not satisfied, because for that we have some other particles also. We need silt, we need sand. That's why loamy structure is very favorable for the cultivation of our crops. So this is regarding the surface area, students. Coming to the next, surface charges, right? For this, students, you should answer. So before going to start this slide, you should answer, students, one fundamental question. So all of you are almost final year BSc, or some students may completed that BSc and writing the AF exam. Anyway, students, how the charge will be develop in the clay particles or in soil? How? What are the reasons? Come on, you should answer. How the charge will be developed? Come on, students, you should answer. This is a very fundamental question. You have written for many exams, semester exams. You should answer. How the charge was developed on the clay particles or in soil? How the charge was developed? Right? At least after completing this class, you will may answer. So
When
both the external and internal. Yes.
maybe
Yes. Please.
soil solution, water.
Hmm. Okay. I think
The
you are.
ions, the hydroxide ions means that in soil solution the H plus ions will be there, no sir.
Okay, you're giving the name explanation. There are two reasons why the charge is developed on the clay particles. We will see in this slide. Then you have to answer why those charges are coming. Okay, just listen. You have some basic idea, I can understand. But after completing this slide, you should answer what are those words. Okay, let's see the class now. So both the external and internal surface of the soil colloids carry the negative and or positive charge. Most negative charges will be carried out, students, in case of soils. Hardly we can see some positive charges also. Most of the organic inorganic soil colloids. What are, because there are two types of soil colloids, students. We will see in the preceding slides. One is organic colloids, another one inorganic colloids. Both of them often carries, mostly they carries the negative charge. Okay, that's why you find, students, what will happen whenever there is an electric current is passes through suspension of a soil colloids. What will happen? All the colloidal particles will migrate to the anode, the positive electrode, including they are carried the so this indicates the negative charge on the colloid. So when you pass an current or electric current in the soil colloidal system, what will happen? All the positive charge ions, that means all the negative charge ions will migrate to the anode. So this proves that colloids are negatively charged particles. So this magnitude of charge is known as zeta potential. There is a big concept called zeta potential, students. For the coming classes, definitely we will discuss a piece of this about this zeta potential. Okay, so that the presence and intensity of particle charge influence the attraction and repulsion of the particles towards each other, and they're influenced by the both physical and chemical properties. So like these students, the presence and intensity, so the basic charge or the presence of their number, that means intensity, decides the repulsion and attraction between the particles. That is completely depend on by the physical and chemical properties of the particular soil conditions, students. So now students, now you have understood what is the surface charge. Surface charge, most of the particles will have negative charge, students. Most of the organic or inorganic particles. So this is the reason, if you pass a current, actually all those will come to the anode because these are negatively charged particles. So this magnitude of charge is nothing but zeta potential. Zeta potential, it's a point charge. We can see what are those, this zeta potential, all those things. The presence and intensity of the particles completely influenced by the attraction and repulsion of the particles. Completely, it will completely depend upon the attraction and repulsion of the particles and physical properties. So now in next slide we will see what is the reality of the charges. This is what I'm saying. Ionizable hydrogens. Students, now you say how the charge was formed in the soil. One is ionizable charged ions, students. The another one is, I won't say that word. If I say that word, the answer is revealed. Now you should say. One reason. What is that? One student sets our hydrogens will be some released. You are saying you're giving answer, but you should be, will be in a very scientific manner. Okay. It's ionizable hydrogens. Okay? What is the reason? What is the meaning of ionizable hydrogens? What kind of charge will you develop in that? Please answer. Students, there are two types of charges, two reasons why the charges are forming in the clay particles or in the soil. What are those? One is dependent, one is independent. What is the dependent and independent? Think. What are those? Come on, you should answer. You know everything, please. Right or wrong?
Dependent means
Yes, dependent means?
depend on the pH.
Okay. Another one? One answer is
Independent
right.
on pH.
Ah, come on. Not independent. There is one terminology. You're right. Maybe by the effect of my slider word, one is pH dependent charge. Okay, that is completely because of, as you said, it's a dissociation. That means not dissociation, ionization of hydrogen ions will be taking place. That's the reason we will get some negative charge. First of all, we will see the pH dependent charge. How the charges were developed on the clay particle. Now we'll see. These are hydrogen ions from hydroxide, OH ions on the clay particles. Generally, what will happen? The hydrogen OH minus ions, what will happen? This aluminum hydroxide, silica oxide portion of the clay ionizes and leave the H plus ions and leaves the unneutralized negative charge on the oxygen. So what will happen? That's why you can see, students, in high pH we can see negative charge, but in low pH we can see positive charge. Here you can see H plus ion concentration is very high, but in neutral pH we can see some stability, some neutrality will maintain. So that's why the extent of ionization, naturally, students, what will happen? The aluminium, here I see in the here I mentioned aluminum hydroxide. So these are hydrogen ions from the OH minus ions clay surface. From OH minus OH hydroxyl ions, we can see the release of H plus ions. So what will happen? Portion of the clay ionizes and leave the H plus ions. See, like this. Some ionization will take place and leave the H plus ions. See here, some leave the H plus ions and leaves the unneutralized negative charge on the aluminum hydroxide silica. Here I am showing example of aluminum oxide. That's why when this hydrogen ions was formed, we can see some unneutralized negative charges is left out here. That's why, student, this is the reason why most of our clay particles are in negative charge. So that's why this is called the external ionized hydrogen ion depend upon the solution of the pH. Generally, if you want to get this type of charge, what is the reason? Completely depend upon the solution. One student said, sir, some solution, yeah, you have some idea but unable to answer, but good, this is your answer. So what will happen? The pH dependent. So what will happen? The extended of ionized hydrogen depend upon the solution pH, and hence the negative charge are pH dependent charges. That's why this is called this type of ionization or ionizable H plus ions are completely, these reactions completely depend upon the soil solution. Mostly this type of reactions or this ionized ions mostly taken place in alkali solutions, alkaline or basic solutions, high pH conditions only, you can see this type of pH dependent charge. This is the one reason why the colloids will get the negative charge. Is one of the reason why the colloid will get some sort of negative pH dependent charge. Okay, students, are you clear with this? Very first reason, students, pH dependent charge, that is called ionizable hydrogen, that is due to the ionizable hydrogen ions. Okay, this is one reason, students. Students, this is very basic thing. You should know all these things in your past course. Another, okay, one is pH dependent, another charge, another reason for charge. What is that? What is those? What is the reason for another charge? Another reason for getting charge on clay particles or colloids. Any idea, students? Have you ever heard that displacement of one silica with aluminum with magnesium, silica with aluminium, XYZ? Did you ever heard these words? Have you ever heard this? Come on, students. You should answer. Don't keep mum. We are hardly 3 students. Should be very
Yes,
interactive.
sir.
Come on. You should say. What is another reason?
Type of soil, sir. In case of
Type of soil. Oh, you are giving after act. Not. What is the reason? How the charge is developed? One reason is
disassociation.
pH. Entama what?
Disassociation.
Cation exchange
Dissociate.
capacity.
You're going to next level of soil colloids. Not like that. Have you ever heard isomorphous substitution? Isomorphous substitution. Have you ever heard about that? Okay, actually, students, I think you may know, but you may forget about all these things. There are two reasons, students, why the charge was developed on the clay particles or in colloids. One is pH dependent charge. Just now I explained, because it's completely ionization of from hydroxyl ions. There will be release of H plus ions. So that's why the reason they will leave the negative charge on the clay particle, that aluminum hydroxide oxide. So this is the reason why the clay particles will get the negative charge. But this reaction is completely depend upon the pH of the surrounding solution, soil solution. So that is why this type of charge is completely called as pH dependent charge. This is one reason. There is another reason also, student, that is called the pH independent, or now you will see that isomorphous substitution. Okay, student, this is one reason, what is called isomorphous substitution. Substitution means result. Just for example, students,
Sir,
say for example, just now we will talk some funny things regarding with the science. See, uh, there is a one person who can work, but very strong person is there, very big. Wait, I will give some example. There is one candidate, very young, person. He is working in a some room. He is working in one room. He is working very good, and he can complete the work within 4 days. Okay, his capacity is like this. He had a good amount of energy. That means he can complete the within 4 days. Okay, so there will be no work will be completed. So there will be no work is left out here. That means here the work is neutralized. No problem. Nothing is there. Everything is stabilized. Another reason, there is a candidate who is very lethargic. He can't. That means, oh, you should not say he's lethargic. He may good at one work, but he may not good at this work. In this room, he may not be fit, but he was forced. He got a chance to work here, so he came to here. He just only completed only half work, so it took more than around 6 days. He take work. So how many days he take extra? How many days he take extra? How many days? Please, at least you answer for this. How many days? How many days? Oh my God, one student had gone. Okay, please, you two, please answer. How many days it takes to come? How many extra days he took for complete one work?
2 days, sir.
2 days. So here there is no neutrality. So naturally there is some. So work was taken extra. So it took 2 days. Same thing was happened, students. So instead of people, you consider this person as silica. You consider this person as silica. You consider this person as magnesium. Just now have shown in this image. This is what I'm going to explain. So naturally, student, this isomorphous substitution is nothing but substitution. Is nothing but replacement. Now I come to the reality of my lecture. So substitution, you can see, students, this is we will read the first line. This is due to the substitution of cation of higher valency. Higher valency very strong. Just for that example is for understanding, student. Don't write in all these things, all this nonsense in exam. Okay, this is due to the substitution of cation of higher valency with another cation of lower valency. But similar size and structure. Both are good. Both are good in their own, but size is similar. But it is substitution of higher valency with it is a substitution of cation of higher valency with another cation of lower valency. Please don't confuse this. If the condition was reversed, that you may get positive charge, that is another subject. But for this you just remember cation of higher valency with cation of lower valency, replaces of substitution of cation of higher valency with another cation of lower valency, but similar size and clay and structure. In clay crystal, some ions fit exactly into the mineral lattice site because of their convencible size and charge, just like these two. You can say net difference is around -2 because it is a 4 plus, it is 2 plus. So the difference is -2. That's why we will get a negative charge. In the clay, so dominantly what will happen? Silica and tetrahedron sites and aluminum hydroxide. So these are the basic structures you have already learned. Silica and aluminum hydroxide. So other ions present a large amount during the clay crystallization can be replaced can be given a replacement of aluminum silica. Naturally, what are the common substitutions? We can see iron, we can see both forms of iron. You can see magnesium, ferric and ferrous, and both magnesium and zinc. So here I quoted the magnesium example. So what will happen whenever there is a replacement of higher cation valency with lower valence cations with a similar size, you can see some net difference. You can see the charge difference will be there. So it will leave some negative charge, unutilized negative charge to this one. So that what will happen? We will get the negative charge on the clay particles. As the total negative charge from the ions oxygen remains unchanged. So naturally there is no change. There will be no change. What will happen? The lower positive charge of the substituted cation results in excessive negative charge. So everything here was satisfied. All the oxygens are satisfied. But here the negative charge is not satisfied. That's why you can see some results of -2 charge. That's why the charge was very less. So the charge was exceeded. Excess negative charge will be left out on the clay crystal lattice. That's why this is another reason why the isomorphous substitution, nothing but fitting of one higher valent cation with lower valent cation. So what will happen naturally? There will be low charge. So naturally there will be some unsatisfied charge will be this. That is recognized as negative charge. So there is no satisfaction. That's why we went to the negative. That's why -2. So net difference will be around there. So the net difference is -2. That means it is negative charge. Are you okay, students, with this isomorphous substitution? Do you have any doubts? Means please. Does you ever heard about this in the pH dependent charge and isomorphous substitution? Please answer. Is it okay? Are you answering? Please.
Yes, sir.
Yes, sir. So you have got clarity what is isomorphous substitution and the pH dependent charge or ionization of OH ions.
Yes, sir.
Okay, fine. Anyhow, isomorphous. This is the reason of isomorphous substitution. Please, students, don't be half knowledge. Learn, like if you're learning something means learn completely. That will be very useful for your examination. Anyhow, students, in the next time I'm going to the next question, absorption of cations. Probably you all know. It's I think very first few minutes you have heard about, you have said about this Adsorption. I think many times when you said that what is absorption? Absorption is taken. Adsorption is only smearing. Is just like if I want to quote very one of my colleague example, is, while you're eating ice cream, you're eating something. It's called absorption. If you're licking an ice cream, it is something adsorption like that. Absorption is a surface phenomenon. If you want to speak very scientifically, absorption is a surface phenomenon. Absorption is something different. So naturally, what will happen in students? All the colloids are negatively charged, and they attract what they will attract. They will attract the positively colloids. So naturally, what they will attract? These colloids will attract H plus, aluminium, calcium, magnesium. All this will apply, and this will gives to the ionic double layer. What are the different double layer theories are there? Please give students, what are those double layer theorems? Come on, just say that headings. No need of explanation. What are those double layer theorems which you have learned in your 4 years of your career? Double layer theory, Stern theory, many things. I think pixel layer theory, some Stern theory, Helmond's, some Stern theory is there, triple layer theory is there. Many things is there you have learned, na?
Diffusion of exchangeable ions.
Diffuse double layer theory. I was talking about that. Yeah. So all this will happen due to because of this of adsorption. Okay, students. Naturally, the isomorphous substitution the colloids makes the external internal layers of the clay particle negatively charged, and this surface will act as a huge anions which forms the internal layer of double layer. So actually, student, I'm just leaving this up to here. Further coming class, those double layer, triple layer, all those things. The outer layer is made up of swarming loosely held cations. And what will happen? And what will happen? The outer layers are loosely held cations attracted to the negative charge of the surface. So that's what now, students. If the particle is negatively charged, what will happen? First layer is very strongly fixed. But when we move far away from the colloidal surface, what will happen? The holding capacity will be reduced because the influence was very less of the cations. So that double layer, that layer thing was very less. These are very different things we will learn very later on. So this is regarding adsorption of cations or absorption of colloids will be like this. This is the reason, students. And coming to the next one, adsorption of water molecules. Naturally, colloids, a large number of water molecules associated with soil colloids. Naturally, some water molecules are attracted, absorb the colloid and said to be hydrated state. Naturally, if some any colloidal or absorbed water means what will happen? Those called hydrated. Those colloids will be in hydrated state. Other molecules which are held in internal surface of the clay. Surface of the colloids are clay particles. Naturally, some water molecules trapped in the internal particle, internal interlayers of the clay particles. That is one reason. And these water molecules plays a crucial role in determining both the physical and chemical properties of the soil. Naturally, these colloids which absorbs the water completely plays a major role in our absorption of water molecules. And coming to the next one is nothing but cohesion, adhesion. What is cohesion? I won't explain this slide. You should explain to me. What is cohesion? Please answer what is cohesion and what is adhesion. There are two
Attra-
only. Come on.
attraction between the similar molecules. Dissimilar molecules with addition.
Simple. That's all. That's all. That is what is adhesion and cohesion. Attracted between the similar molecules, similar materials. Uh, Cohesion indicates the tendency of clay particles and stick together. Generally, the attraction of similar particles, especially in clay particles, the tendency to the attraction of clay particles or water molecules held them together. So, due to this reason only, due to this cohesion only between the water molecules, held the both particles very strongly. When the colloidal particles are wetted, water first adheres to the individual clay particle and then brings them to cohesion between the two or more adjacent colloidal particles. So, this reaction plays major role in our activity like formation of beds or clots, all those aggregates is then this is one reason why the cohesion will take. Adhesion means nothing but with dissimilarity. You can see some attraction or aberration, dissimilarity will be there. It refers to the attraction of colloidal materials to the surface to any other body or substance which come in contact with any other foreign particle. Any other foreign particle means whatever we have applied, whatever any particle, what may be some of our organics, whatever might be, they attracted to the attached to the clay particle. So this reaction is called as adhesion. Both are surface chemistry phenomena. So all those things. So this is a very simple thing. Cohesion, adhesion, students. Probably you may get some by giving some examples. They may ask which one is cohesion, which one adhesion. But be practical, students, because examination pattern was day from year to year. They're increasing their level. So you should be very smart while giving answers. Okay, please be applied man. Swelling and shrinkage. Especially we can see this due to some colloidal clay materials belonging to the Smith-Side group like Montmorillite. Especially we can see what will happen. Okay, you can see the 2:1 expanding type of clay lattice. What will happen? There will be some swelling and shrinkage. All propelled by the dry, especially in dry seasons. What will happen? There will be big cracks will become in the presence of Smith-Side clay, especially in black soils. We can see big cracks will become. What will happen when like, these cracks are allowed to? What will happen? These cracks will allow the water flow inside them. Later they will become swell and become impervious. That means they will become the surface will be the bulging, the hydration will be more. At the same time, but soils belongs to the kyanite, chlorite, and fine grained materials do not swell or shrink. Generally, this group of materials, this group of clay minerals like kyanite, chlorite, and fine grained materials do not swell or shrink. Especially vermiculite is somewhat intermediate between them. So vermiculite is very somewhat intermediate because in vermiculite we can see some potassium also will be there in between them. So that is why you can see some very limited or intermediate swelling. That's why it's called 2:1 limited expansion type. Vermiculite is called as. That's why we can say vermiculite is intermediate between the swelling and shrinking characteristics. Another one is called dispersion and flocculation. Generally, student dispersion and flocculation, generally as the colloidal particles remain negative charge, they repel each other and suspension remains with. Yes, students. Yes. Okay. So generally, what will happen as long as colloidal particles remain negatively charged, what will happen? They repel each other, and the suspension will be stable. If on an account they lose their charge, or its magnitude of the charge is reduced, what will happen? The particle will be coalesce and form a flocks or loose aggregates and settle down. What will happen? They will lose something. They will come in each other. They will form a flakes. Flakes means some flaky structure will form, and loose aggregates will form out. What will happen? They will settle down. This phenomenon of coalescence or formation of floc is called flocculation. Remember these terminology, students. Flocculation, flocks, formation of floccles are called flocculation. If the process was reversed, what will happen? Individual particles will be dispersed. They break down. The aggregates will flow, break down. Deflocculation will be there. There will be far dispersion will be there. All our physical properties of the soil will completely will be dispersed. This is the major reason for between the dispersion and flocculation. To the next, Brownian movement. Have you ever heard about this Brownian movement? What is the meaning of Brownian movement?
Yes, sir.
What? What is the meaning of Brownian movement?
Movement of colloidal particles, sir. In the suspension
Yes.
is known as.
That oscillation. If you see in a microscope, you see some oscillations. Suspension of colloidal particles. If you see on that oscillation, the oscillation is due to the colloidal particles of molecule, which is their suspension in that medium. Suspension medium is there now. That oscillation, that movement is called Brownian movement. Soil colloidal particles, those water in which they are suspended are always in constant state of motion. So there will be constant state of movement. Motion is nothing movement. The smaller the particles, the more the rapid is the movement. If the particle is very small, you can see more movement will be there. Just like our clay particle students. I think students, have you ever done the experiment in your BSc? Have you ever analyzed the texture in your laboratory? Students, only 3 students are there. 3 of you have ever done an experiment of soil texture in lab?
No, sir.
Oh, you didn't do the texture in lab in BSc.
No, sir. We don't have that much practical classes.
Come on. Texture is very simple. Like hydro, any method, 2 methods is there. Hydro, that what is that? 1 meter is the hydrometer or something. One hydrometer is there. Another one is called international pipette method is there. 2 methods are there. I think doing international pipette method up to a BSc level is not fair. It is not good. No one will. It is very difficult. But definitely hydrometer method is there. Na? Have you did? Have you did?
I don't know.
Okay, no problem. Yes, Lavanya.
I'm telling no, sir.
Come on, all are from Bapatla, so you should do this. So okay, anyhow, I'm going to explain now. Actually, what we'll do means, students, we will after suspension, when the soil was completely treated with H2O, all those similar procedures, what we'll do, we will tilt the jar. We will tilt that cylinder up and down, up and down. What will happen? Clay particles, if you see, if you observe very carefully, clay particle movement will be very, very fast. The movement will be very, very fast. Whereas sand particles will slowly will be settled on. Immediately will settle down. This is what the Brownian was explaining. The particle was very small. What will happen? The movement will be very more. So I mean, that's why this clay also will have some colloidal properties because of its size. This is the reason of Brownian movement, students. Remember this one, this word, Brownian movement. They may ask some question. Okay, next. Non-permeability. Non-permeability. Another word called colloids, as opposite to crystalloids, are unable to pass through the semi-permeable membrane. So these are very difficult. They can't go through the. They are completely opposite to crystalloids. Even though colloidal particles are extremely small, they are bigger than the molecules of crystal dissolved particles. So the permeability was very less when it is completely opposite to crystal. So the membranes allow the passage of water and the dissolved substance to its pores, but retain the colloidal particles. Generally, students, this non-permeable membranes, what will happen? They won't allow the colloidal particles. They allow only the dissolved substance. So colloidal particles cannot go through the non-permeable membranes. This is one reason of a colloidal region. So remember, colloidal particles cannot pass the non-permeable membrane. Simple word. Okay. Next one. Types of soil colloids. Finally, we have reached over the what are the different types of colloidal regions. So students, there are four types of solid colloidal, students. One of this layer silicate clays, because clay itself is qualified as a colloid because of its size. Iron and aluminum clays, because of just Q oxides, we call iron aluminum oxides clays. Another one is called allopane and associated amorphous clay. There are another form of this, another allopane and associated clay minerals. And fourth one is called humus. Students, these three are called inorganic colloids. This fourth one is called organic colloid. So these are reason. These are the four different type of soil colloids are there. One is layer silicate clays and aluminum oxide clays, and third one is called allopane and associated amorphous clays, and fourth one is called humus. So like that, we have a different four type of clays are there. Now we will see the next one. So layer crystallitis, especially students, the important silicate clays are the phyllosilicate students. Students, we will learn in next class what is phyllosilicate. This is one type of structure. Phyllosilicate, because of their leaf-like and plate-like structures. Because of this, these phyllosilicates will have some plate-like structures. That's why this one type of these are many made up of two kinds of horizontal shears. One is dominated with the silica and another dominated aluminum or magnesium. Like this, students. One is silica. This is silica tetrahedra, octahedra, tetrahedra. Again, in between there will be some exchangeable cation. This is called the silicate lake illustration. Generally 2:1 only, all those things. So the 2:1. Okay. So one is the one layer is tetrahedra, one is octahedra, one is tetrahedra. This one layer lattice. And in between these layer, the similar structure will be repeated here and downward. In between there will be some exchangeable cations. So this is called the layer lattice structure. Due to this leafy structure, there will be some sort of colloidal nature will be there. This is one reason. Now this is about the layered silicate clays. And in this trend, you know what is silica tetrahedra? Almost you are reading from intermediate chemistry to up to here. Everywhere you may aware about this. This will be next size, student. For our vision, it will be in top, but it won't be top. It will be in top. There will be another layer. Oxygen will be shared. It will be another side end of the silica tetrahedra. So this is a very basic building block of silicon dominated silica sheet. In silica sheet, this structure is majorly dominated, composed of one silica atom, generally one silica atom surrounded by the 1, 2, 3, 4 oxygen atoms. It's called the silica tetrahedra because of the four-sided configuration. There will be four-sided configuration. Okay, there will be four. Sorry, it is sorry 1, 2, 3, 4. Yeah, four-sided 1, 2, 3, 4. Yeah, one is up. Yeah, I'm sorry, is on top only. So there will be four silica tetrahydrates, and there will be interlocking array of series of silica tetrahedra tied together horizontally and share the oxygen ions in the given tetrahedra. So naturally, what will happen? There will be four charges, so all the charge will be satisfied of the silica. Naturally, the structure will be very stable. structure will be very stable, and this form the silica tetra. And this is a very fundamental unit structure for our lattice, our crystal lattice, what you have taught, what you have seen in the previous slide. And coming to next one is called octahedra. This is another structure, students, another octahedra surrounded by the surrounded by the six oxygen atoms or hydroxide groups, giving an eight-sided building block term. There will be some eight-sided blocks will be there. There will be eight-sided things there. So naturally, aluminum or magnesium will be there. Around the six oxygen atoms will be given. So numerous octahedral linked together, horizontally comprised of octahedral sheet. An aluminum dominated sheet, also known as, if it is aluminum, with the dioctahedral sheet, whereas one dominated by magnesium is called trioctahedral. Why it is called diocta and triocta? Because the distinction is due to the phases of the two aluminum two aluminum ions, and in dioctahedra satisfy the same negative charge, forming a surrounding of oxygen and hydrogen as the three magnesium ions in the trioctahedra. So there is charge difference only because of satisfying of charge, that is called the diocta. Magnesium is called the trioctahedral sheet. This is both the diocta and previous aluminum octahedra, silica tetrahedra, both are the basic fundamental structure. We will read about these two structures in the next class on clay lattice. Very interesting thing here. So naturally, this tetrahedra of the fundamental structure of silicate clays, as I explained, these sheets are bonded together with crystal shaped oxygen atoms, as I said, because combination of these sheets are form one type of clay to another both. So combination of these sheets we form a different clay crystal lattice, and this controls the different physical and chemical properties of the clay. So this combinations, all those things, in next class we will deal about these two in very serious manner. So I'm coming to the iron and aluminum oxide, students. What will happen in iron and aluminum conditions? So what will happen? And very extensive leaching by the rainfall, long-term intensive weathering of minerals in humid and warm conditions, and most of the silicon aluminum, primarily minerals, are dissolved and slowly leached. What will happen? This aluminum or these two sq oxides, silicon aluminum will be gone. Only iron aluminum will be left, and remaining what will happen? Remaining the undissolved, the remaining material which has low solubility are called as sq oxides. So almost after the weathering and leaching, the silicon aluminum will be lost off. So only remaining material will be there. That's called sq oxide. So sq oxides are a mixture of aluminum hydroxide, iron oxides, or iron hydroxides. Iron oxides, iron hydroxides will be there. So Latin word sesq means one half of time. Generally, that is the meaning of one half of time, meaning one half times more oxygen than aluminum and iron. This is the meaning of Latin word. So these clays can be come under come grade from can grade from Well, anyhow, we'll continue. And Nandini, shall we wait or we can continue? Yes. Okay, we can continue. Well, that's all. I mean, in some connection error. Welcome back. Iron and aluminum oxide clays, where we can see only iron aluminum clays only we can see. This is regarding with aluminum hydroxides, aluminum oxide clays. And coming to the next one is called allopian and amorphous clays. These silicate clay minerals, there is no particular we can't see any proper arrangement of silicate lattice structure. Even mixture of other, whether iron oxides may be a part of the mixture. Even we can typically these clays occurs with a large amount of weathered products are exist. These clays are common soils. Mostly we can see in volcanic ash. Most allopian is example. These have very high anion exchange capacity is very more, or even high cation exchange. We can expect some cation exchange also. And also we can see almost all of their charges is in the form of accessible hydroxyl ions. We can attend positive charge, positive ion, or lowest the H plus ions. So all these things, actually this particular sector is there will be special separate class will be there regarding on this clay lattice. These clays have a variable charge depend upon the H plus ions in the solution. So mostly it's completely this allopen or completely on charge is completely depend upon the H plus ions in the solution. Coming to the next, humus. Finally, we have reached our the organic colloids. Especially humus is amorphous. Actually, there is no any proper structure. Dark brown to black, nearly insoluble in water, but mostly soluble in dilute alkaline. Sodium hydroxide. We can say sodium. There is a dilution of sodium hydroxide, potassium hydroxide solution. It's a temporarily intermediate product left after the considerable decomposition of plant animal. Mostly these are all from products, all decomposition products of the plants. You can see some organic substance remains under decomposed slowly intermediate, and often this humus often referred as organic colloid and considered various chains of loops of interlinked carbonate. Actually, humus is very complex material, so there will be linked carbon atoms, and this compound basically of the composition mostly of carbon, hydrogen, and oxygen rather than the silica, aluminum, iron, oxide, hydroxide. Mostly this organic colloids basically composition of CHO, that is carbon, hydrogen, oxygen, when compared to other colloids, other inorganic colloids where we can see only silicon, aluminium, and iron, oxygen, and hydroxyl groups. The organic colloid particles vary in size, but they may be at least as small as silica clay. I mean, naturally, the size is very small in compared to other inorganic colloids. Negative charge of the associated partly with the dissociation of ethyl and carbonic. These are the functional group, students. You know what is a functional group in our organic chemistry? You know, this is due to the presence of the dissociation of enolic and carboxyl group and phenolic group. Phenolic groups, these groups in turn associate certain unit of varying size and complexity. So these are the main reasons of their negative charge in the humus carboxyl and various size complexes. So, and what are the major difference, students? Actually, these are please remember this is the important things. Humus is made up of carbon, hydrogen, oxygen, whereas clay is made up of silica, aluminum, of oxygen. Complex and amorphous, or these are very complex and will be amorphous in nature. Here it is inorganic, and there will be proper crystal lattice will be there. It is a more dynamic formed by the destruction. I mean, all the decomposition, everything will taking place due to that decomposition factor. Only we can see here some formation of humus we can see, whereas clays and stable relative. So here we can see some stable clays actually is the structure will be very complex, and even it's very difficult to analyze it. But here we can say very defined structure will be there. In clays we can see very definite structure will be there. That's why we have seen many type of clay lattice like Mount Monland, vermiculite, illat, some like that. We have seen many clay lattice. There is a major difference. These are the four kind of differences, or hardly we can see between the organic and inorganic colloids. And coming to the significance, what are the significance? So naturally, organic and inorganic in terms of transport of transported via colloidal particles. Organic contaminant or inorganic contaminant, all the waste will be travel or transported through only the colloidal particles. Majority surface area electrostatic residues of less than 1 micro size fraction with the particles of radius 20 to 100 consist of major part of the surface area. So small size, size also matters. Small size, more surface area for reaction. Since major part of the surface area, if the colloidal fraction of this, almost all surface colloids processing, including absorption, there will be almost there will be different kind of reactions will be taken place here. What are those reactions? What are those reactions? Absorption reaction, we can expect absorption reactions, nucleation, we can see precipitation reactions also will be there. So all these reactions are happening in the soil. In addition to these chemical process, colloidal particles are mobile in nature in soil and thus affect not only the chemical transport and otherwise immobile chemicals also. We can see transportation of nutrients because of this, but also extend a strong influence on hydraulic properties also. You can see some, there will be influence of the hydraulic properties. There will be colloidal mobiles, and thus and only not only the chemical and transport of otherwise mobile immobile chemicals also. We can see transportation of all our nutrients. In that, so mobility means we can see some mobility of nutrients, or we can see this colloidal particles will influence the hydraulic property also. So with this very hard lecture, that's all for today. And coming to the next class, students, we can discuss about the structural clay lattice, all those things. While we are going to deal about those clay lattice, we can go very further better what is amorphous and the crystal structure, all those things. Especially we can read many things. Anyhow, student, that's all for today. Thank you very much for your attention. Though there is some disturbance in the network. Thank you very much. Right, Nandini, is there any doubt for you?
No, sir. I'll go through this again and I'll ask if any doubts.
Sorry, bit louder, Nandini.
మళ్ళీ ఒకసారి చదువుతాను సార్, అర్థం కాకపోతే అడుగుతాను.
Okay. You can contact WhatsApp లో చూసి చెప్పు.
ఓకే సార్. ఓకే సార్.
ఇది క్లే గురించి మనం నెక్స్ట్ క్లాస్ చూద్దాం. అది పర్టికులర్ లెక్చర్, అందుకే ఇందులో నేను టచ్ చేసి వదిలేసాను అంతే. ఓకే, we can see in next class.
ఓకే సార్.
Thank you.
థ్యాంక్ యూ సార్.
Thank you very much.